I have fucking 6 browsers running on this phone. It's great, and not all of them are based on Chromium. Hello. Welcome to Security, Cryptography, whatever. I am Deirdre.
I'm David.
I'm Thomas.
I'm a cryptographic engineer at the Zcash Foundation.
I don't know, what am I? I did some stuff once. I'm a has-been at this point.
Nah.
I'm the type of person where someone calls me up because they're in school and they're like, my professor told me to call you about this thing you did 8 years ago.
You have a legacy.
I'm a punching bag at fly.io.
Today, we did not have a guest. We never intended to have guests. We just ended up having some amazing people who we wanted to talk to and let us talk to them on our podcast. So today is a bit of a roundup of both circling back on some of the episodes we've done before and also just sort of a news roundup of security things that are both catching on fire and making us happy. Let's see. Pertaining to our one of our more recent episodes with the inevitable Ryan Sleevey, DNSSEC.
I'd like to think of it as the inevitable Ryan Sleevey. He's like Thanos.
I am inevitable. Yeah, the inevitable Ryan Sleevey. We didn't talk enough about DNSSEC.
Yeah, like if you missed it, it's my favorite thing that we've done so far, right? So Ryan Sleevey runs the CA root program for Google. So basically, Ryan is one of the people that controls, who's allowed to have trusted certificates in your browsers. It was a good conversation. He told us all how to, be our own certificate authorities, which any day now we will all be. And at the end of the conversation, I sort of mentioned to Ryan that we're probably at a point where we can kind of stick a fork in DNSSEC, declare it dead. We had a whole interesting conversation about like the ecosystem of how they, do CA trust and things like that. And Ryan shoved an ice pick through my heart and said that the stuff that European governments are doing with government mandated certificate authorities is probably going to mean that they're going to have to consider doing something with DNSSEC and DANE in particular. And DANE is the thing where you use DNSSEC as a certificate authority. And he seems to believe that it's happening. But yeah, so that's a thing that happened. And I'm a little bit speechless about it. So David, I think...
Still reeling.
You have the take here, I think.
Yeah, well, I think I should be able to make you a little happier because I think there's just so much that needs to happen kind of organizationally from a that needs to happen in terms of technology policy for DNSSEC that has been happening with HTTPS and certificate authorities that just simply has not happened with the registrars. So really, if you think about the HTTPS and WebPKI and then the kind of base level of validation, which is domain validation, where you prove that you own a domain by setting a DNS record or serving a special file, and then you get a certificate. A kind of straw man description of it is that it's a very convoluted system for basically delegating trust on first use to a CA. There's not actual sort of corporate person valid, no one is coming to your house and showing that you actually own the domain and you are an authorized representative of the person that claims they own the domain, right? And for good reason. I don't think we would be in a better world where that was happening. We're really building a system where whoever's kind of had the domain the longest gets to have certificates for it without it looking weird. And the reason for that is certificate transparency, right? Is that when a CA issues another certificate for your domain, for it to be trusted in browsers, it needs to be added to the CA log, to the certificate transparency logs. And if it doesn't get added to the log, then it won't be trusted, which has the side effect of, if it gets misissued because someone hijacked your DNS, it should eventually end up in the log. And so in that sense, you're just getting the same certificate that everyone else is getting.
Yeah. And you can check that. Then that's the whole point of the transparency, which is, given some qualms to some people who like, well, I want my certificate to be trusted, but I don't want to advertise like a product that is not yet been launched, but I want to get all my ducks in a row and have my certificate be trusted by Chrome or anyone else that requires that you have like a ticket, whatever they call it, an SCT, in every time that you're negotiating your TLS connection without leaking the fact that they have, mynewproduct.com in the certificate transparency log. And I think there's some workarounds for that now or something like that.
There is some form of, I forgot what they called it, like blinding, but I think that might have been gotten rid of. It's only in the next version of CT, RFC 6962 biz, which just also doesn't really exist. Like for whatever reason, version 2 was standardized, or mostly standardized a while ago, and then everyone just stuck with version 1.
Yeah.
Someone who pays attention to WebPKI more can probably correct me on that. But the point that I'm going with is that, especially once you introduce gossip to really verify that, the SCTs you're seeing are the same as everyone else's, or that, because the SCTs are really just a promise that it got added to the log. It might not have been added to the log. So there's a convoluted scenario where someone issues you work with the CA to issue this SCT and then never actually add it to the log. But the browsers are supposed to check that they're going to actually be in the log eventually, and you can talk to other people. So basically, it's fairly difficult to issue a certificate for a domain and actually not have anybody notice nowadays. And it's basically impossible to do that with DNS, because half the value proposition of DNS is that you can serve different IPs to different people. This is how DNS load balancing works.
Yep. This is how you can get region, not load balancing, but we want people, if they call up a google.com and they're located in, say, Turkey, we could just be like, maybe we'll redirect you, or maybe we'll suggest to you Google TK. I don't know what the TLD for Turkey is.
Yeah.
But and then redirect when anyone who hits google.turkey can go to that whole infrastructure that is localized for them, has language for them, has all the infrastructure to serve them rapido, as opposed to going around the world. And DNS is a big part of that.
Exactly. And so there's this whole system for detecting for basically visibility into WebPKI that just doesn't exist for registrars, to then say nothing of the organizational audit and policy requirements, like the BRs that Sleevey was talking about. I mean, there certainly are rules to be a registrar, but I'm not under the impression that they're the same kinds of rules that would apply to a CA. And so I just think there's a whole, when people talk about switching to DNSSEC, there's just this whole host of improvements in WebPKI over the last 10 years that are just non-existent in the DNSSEC world. And that's before you even get to talking about why are they using weird old crypto. I'm fine even hand waving and saying let's assume all the crypto gets better. Let's assume somehow the clients get updated. Finagling registrars to behave with a security posture at least as good as certificate authorities do now, or at least the good ones, are just seems totally out of reach for a very long time without a major external pressure.
We need DNSSEC CT. We need DNSSEC transparent. We need blockchain for DNSSEC, because that's with all fucking Merkle trees all the way down.
Well, the thing there though is you don't necessarily want to serve the same thing to everybody in DNS, right? That's what we were just talking about. So I don't even know that that's feasible. So I don't see DNSSEC going anywhere until you solve some of those things, and I think that no one's really talking about that.
I feel like I might be the internet's foremost noisy hater of DNSSEC. It is like my calling card on the internet is disliking DNSSEC, and I have a long catalog of problems I have with it. I think a thing to pay attention to here is that, and maybe I'm just trolling Ryan Sleevey into correcting me on Twitter, but a thing to pay attention to here is that Google has market power and kind of institutional power versus the certificate authorities, right? Ryan Sleevey doesn't, but we generally cast the certificate authorities, except for Let's Encrypt, the certificate authorities as the bad guys in the internet trust, kind of story, right? They make money selling people. Yeah, they make money selling people certificates. They don't make money making certificates safer. And, the perception is that they're generally an obstacle to getting, better internet trust deployed. And I think that's probably mostly true, right? Mm-hmm. But like Google can kill a CA, right? Google has killed a CA. Google has killed some of the largest CAs that there are, right, for policy violations. And there's decades of history built into how Google gets to do that. Not just Google, like Apple could do it, Mozilla could do it, Microsoft could do it, right? There's decades of history into how that works and what the institutional power they have is with respect to policies at the certificate authorities. I don't believe that exists, not just like the functionality that David is talking about, but like institutionally the ability to push that stuff to the registrars, right? Like for me, it always comes down to Google can kill a certificate authority and everyone will scramble to a new certificate authority to get out of the, the blast radius of Google killing, VeriSign or whatever it is they killed, right? Mm-hmm. And that works because it's pretty straightforward to switch certificate authorities, right? You can't switch out of .com. Right? Yeah. If .com is misissuing or not following policy or being an obstacle to deploying, if Google was to declare, okay, there's going to be no 1024-bit RSA anywhere in the DNSSEC hierarchy, or we won't honor signatures for, this domain or whatever, right? Like you can't jump to .com to a different .com. That doesn't exist, right? Mm-hmm. And like I feel like there's an answer to this where it's like, and I think Ryan Sleevey said this, right? Like, well, this is a reason to be careful about what domains you're on, right? But the reality is that Google in particular is locked to some, to specific domains that they have to be on, right? And if those domains and the people that are managing them aren't behaving, there's no recourse, right? Mm-hmm. Like the registrars could very well win where the certificate authorities lost this battle before. Is like one of my many concerns I have with that, with DNSSEC.
That's funny because I didn't even think about that like, you can take your google.com and you can go certificate authority shopping and you just keep google.com forever and like whatever, but you can't shop around for you can't register it again and again. You register it once.
I think that the counter argument would be that like you would see basically what happened to Symantec kind of happened to .com because DigiCert bought the Symantec certificate everything as it was getting shut down and basically it's like, hey, Symantec customers, guess what? Not only can you not use it anymore, but also we have it. Let me tell you about my good friend DigiCert/Citigo, right? And so there's the counter argument might be that like, yeah, you can't get rid of .com, but you could transfer whoever is controlling .com to someone else or controlling that aspect of it. What would be the only like feasible way to work around something like this that I could.
But also, like Google is only now getting control over the certificate, the certificate stores themselves. Mm-hmm. Like Chrome is taking control of what certificate stores there are, but up till pretty recently, they did not. They relied on the operating systems to do that for them.
Yes. But they still
have that problem.
They still had
more so with DNS.
Rules on top of that. Like you could do somewhat weak chaining with the operating system, and then on top of that, like enforce additional constraints. Like, for example, when Heartbleed happened, they manually inserted some code that checked for the Cloudflare speaky that they revoked for like all of the Cloudflare cert. They just stopped using one of their certs that corresponded to all of the Cloudflare certs that were Heartbleed compromised. And so there's other checks like that. That's how they enforced some of the distrusts. I mean, that's how they enforce the distrust of Symantec, even, like, because I don't think their root store is shipping, or at least it's not shipping everywhere. So you end up with extra code, like, within the TLS stack that just looks at the result of the operating system verification and enforces additional constraints. It's still way better to do the verification yourself because there's so many different ways to chain a certificate in the common case that, like, you kind of want to know all of them before you make the decision, whereas many APIs will just give you back one of them, and there might be another one, and if you don't like the one it gave you back, like, you're SOL. So there is space to do before you to do policy before you even control the root store, and in fact, it's what Google's been doing for years. I don't think that detracts from your point at all, though.
The only other thing I have to say about DNSSEC is that I have many, many more arguments besides this argument.
You got to go down to your argument vending machine and...
is the only reason DNSSEC hasn't already moved to curves is that I think Sleevey told a story of like they tried to deploy like minimum DNSSEC and it broke some VP of Google's like networking hardware that they had deployed in their house that like hadn't been touched in like 20 years. And they had to deploy engineers to figure out why they broke the VP's network. And it was because DNSSEC, because the old DNS can't handle like 500 bits of RSA in the thing. Is that...
This is such a can of worms, right? So when you think about the Web PKI, there are a lot of code bases and a lot of installations that make the Web PKI actually work, but it's like a relatively constrained number of installations that there are, right? For the DNSSEC hierarchy, by design, DNSSEC it's 1980s distributed. It's not distributed in the sense that we would mean today, but it's, so the authority over DNS records is distributed over thousands and thousands of different organizations. Everybody who owns a domain, in a sense, has control over how that domain is administered and what records it's going to support and what software it supports, right? That also sort of goes for the DNSSEC client sides, the things that actually validate DNSSEC records. So like for I think like 10 years now, I think it's Jeff Houston. I think he's at RIPE. I forget where he's at. I should know this. But they've been doing studies on DNSSEC compatibility, and for a long time, Curve DNS was breaking things, not like breaking home routers. Like DNSSEC by itself breaks home routers, right? Like any DNS query that doesn't look like a DNS query that would have been issued in 1995 will break a home router, which is why Google tried and then pulled out Dane, right? But even in like real DNSSEC implementations where you could actually speak DNSSEC to them, Curves for a long time broke things anyways, right? Like, and you can kind of imagine, right? People deploy this DNSSEC software that's kind of built with the assumption that everything is going to be RSA, and they don't have curve support, and curves were exotic when this code was written, or whatever happens there, right? But the thing I think to remember there is that, like, the certificate authorities can upgrade, and comply with, new things pretty quickly, right? But getting a huge installed base of DNSSEC servers updated is a nightmare problem. So you need to fix all of those incompatibilities and also get everyone to issue with the new kinds of, with the curve records instead of the RSA signature records, right? All that has to get deployed. Also, and it's obvious when you think about it, is you don't just have to get people issuing curve-based signatures. You also have to get everyone to stop issuing RSA-based signatures. Otherwise, you're just you're just asking for whatever the lower security of the two of those things is. I don't know how long it would take to cut the entire internet over to curve-based, curve-based signatures.
It's not even on Web PKI. Like,
no,
you might do
not.
a lot of web TLS connections are doing curve-based key exchange, but the signatures are still, or the signatures and the certs are almost always still RSA.
It's really sad. And like I was giving someone crap like, oh man, when do we get Curve 25519 based certificates? And they're like, yo, we're not even on like NIST Curve certificates. Like we're not, I don't know what the numbers are now, but at the time it was like vast majority are RSA based certificates, which is just like
conveniently. I once started a company that literally calculates this number on a day-by-day basis. So let me go check. Keep going.
I think, as you guys are probably realizing, I can go on and on about this topic. I keep giving you opportunities to get off this topic, and you follow up with more DNSSEC questions.
Okay,
so.
Because we can rabbit hole in this all day. Sad panda. If we can't even move off of non-DNSSEC certificates or keys from RSA to curve-based, oh good lord, like. What hope do we have for the most fragile, like written in the late 80s, early 90s DNS infrastructure to do it as well? Although maybe at that point we'll have like the most beautiful curves to move to. Although we probably won't, because it'll all be NIST curves and we're going to be deploying NIST P226 for forever and ever. But that's not as bad as it used to be because we have new curve formulas and they are better now. So that's not so bad. That's DNSSEC. Other news. A
quick breakdown of currently trusted certificates. I'm seeing 592 million using RSA SHA-256, 44.5 million using ECDSA SHA-256, which I think is a NIST P curve, which is way more than I thought, to be honest. A couple confused people using SHA-384 RSAs. They must have a really weird key length or something.
Bigger number, betterer,
Yeah.
right?
I don't even know who you get to issue those.
Maybe Google? I don't know. Well over 90%.
Yeah, 91.42% using.
Yeah. And we've had curve-based certs for over 25 years, 20 years, something like that.
Mm-hmm.
Anyway, thank you for doing a startup that could give us this information on the fly. It's extremely handy. Other news, iPhones are on fire. iOS is on fire. All right, we'll start with, there was a story in the MIT Technology Review about how U.S. company Accuvant sold exploits in iOS to the United Arab Emirates, and then United Arab Emirates used them against, I don't know, quote-unquote terrorists, not terrorists, people they call terrorists, but we would call activists, journalists, stuff like that. And that dovetails with this week, or the week of the 17th, Apple patching all their platforms. iOS, macOS, iPadOS, watchOS, all the OSs, because they were patching a 0-day exploit found by the research group Citizen Lab at the University of Toronto that they called forced entry. They found it by just kind of getting I think it was they found it because they got a list of NSO groups' possible targets. And this is kind of just like, don't ask how we got this possible target list. We just found it, and then we started contacting them to be like, do you mind if we look at your devices? And some of these are like family members of Saudi nationals and Saudi activists, such as people who knew Jamal Khashoggi, who was murdered by a Saudi royal family. Turns out that their devices that they were using around the same time that he was murdered were full of this no-click 0-day in iOS that was eventually patched by Apple after about, some say a week, some other people have said like almost 20 days from when they sent a crash log to Apple to when they actually released the patches this week. I think it was the 14th of September. I think they said from when they delivered a full exploit to Apple, it was about 6 days. And related to some of our ranting about Apple security and previous episodes, but also about like how do you secure platforms like this and like have a secure software program and how do you patch? And basically, Apple they claim that they patched this as expeditiously as possible. And basically all the information indicates that no, they released it in about their regular patch cycle. And if you cannot get out a patch for your platforms in less than your normal patch cycle for something like this, which was a no-click exploit vulnerability in WebKit and their general media parser library, and I forget the name of it, so that you could have a malicious PDF that looks like a GIF, and you can just push it to someone. They don't even have to click on it. It would get parsed. I think the vector to actually hand over this payload was iMessage again, that it would execute, and then it would persist until reboot. If you rebooted the phone, it would wipe it, and they would have to do the exploit again. Yeah. Everything's broken.
So the one thing that I'll say and then tear down is that like I can't imagine it would be possible to do a release in faster than 3 days. And that's like an insanely fast release. Right. Probably 5 days, like a business week, realistically, because that's like a data patch, at least a day of building stuff, and then a day to actually release it is like your 3 days. And assuming you want to like do like release testing and there's, add on another day or two. Like that's realistically the fastest that I think a release like this could happen.
But this would qualify for that.
Yeah.
Would it not?
They hit it in 6 days, but I think the takeaway is that they actually hit it in like 14 days. Because like that trace should have been enough to do the patch. So you can kind of assume that they actually did the patch on the trace, and then it took another 14 days or whatever it was for them to push out the release on their regular cycle. Like sure, they can say they might kind of imply they did the patch like once they saw the exploit, but realistically they could have patched it with the backtrace, and then you're looking at a not particularly fast timeline.
Yeah.
I mean, it's not a 1990s timeline, but like...
Yeah. I'm looking at the specifics both from the patch notes and from the Citizen Lab write-up, which is very good, and we'll add links to our show notes. The actual patch notes, and like, I kind of was talking about this somewhere else, that like, when you got a bunch of OSs, you've got iOS, iPadOS, macOS, watchOS, you know, there's another OS somewhere, like iPod Touch, you know, because of course iPod Touch has a fucking browser in it, because everything has a fucking browser in it. Yeah, you've got a bunch of those that you have to go through, you know, quality testing, and then before you push it out. But they were all using the same components. They're all using core graphics and WebKit, and these are the things that they're shared. Like, this is the pro and con of having a shared dependency, especially as someone who works on fucking cryptography with a ton of shared dependencies, because some of them are very bespoke. If you have all your eggs in one basket and you secure the fuck out of your basket, maybe you can deal with that. But if everyone is sharing the one basket, so if there's something wrong with the one basket, everybody gets fucked. And like, the other side of it is like, you can have multiple implementations and you have to do the trade-off of maintaining multiple implementations, making sure they're compatible, make sure that you're not reproducing bugs or security vulnerabilities between them. But then, you know, maybe you won't all get bit by the same fucking vulnerability all at the same fucking time. So yeah, I want to kind of give them the benefit of the doubt that when you're maintaining all these OSs, even if they're sharing the same components, you have to take a few days to do a quality assurance and get it out, make sure you're not going to brick anything. But like, if you had a trace for 2 weeks or more and it took you this long, and this is the showstopper. Like, they did not find this. They, like, a third-party research org found this on their own investigation and were talking about it for weeks. And Apple only finally did something after they kind of were like, here is a full exploit chain, and it took them this long to push it out. That doesn't feel good. It feels like they cannot, by their organization and their, you know, security software deployment system, move fast when they need to, and that is a problem.
Do we like have people reversed the patch yet? Like, do we have like good intelligence about how much got fixed in that patch? Like, another thing that happens, like, we have the 3-day thing for, like, you know, identifying and then QAing and then you know, deploying the patch, right? But there's another step in, like, in the common case for when vulnerabilities are reported. There's another step in there, which is you go look to see if there's, like, if it's systemic, if there are lots of other instances of that thing, which also takes time. And you can imagine, like, there being problems with, okay, so this vulnerability is reported, and, like, you know, 45 minutes of scouting in the code shows you that there's other places where that's potentially vulnerable. All of those need to get fixed as well, especially because the patch conclusively identifies the pattern for the flaw anyways, which is a thing I think people don't think about that much. But as soon as that patch is, you know, released, you're also, you've got a blueprint to what the vulnerability is there. So you can imagine also, like, taking a minute to make sure that you're not going to have to do a string of updates, because at a certain point people won't update back to back over and over again, because updating is a pain in the ass. So I have no reason to believe that that's any part of what happened here. But another thing that can happen that can blow out patch timelines is just taking a minute to see what else that vulnerability, like, the people that found that vulnerability may or may not know about all the other instances of where that code pattern happens.
Yeah. I don't know if it's been torn down. I'm doing a quick grep. There's something on the Objective-C blog, so I'm going to look at that.
While you're looking at that, I will just say, like, hats off to the Citizen Lab people, especially Bill Marzak. He's the, like, first person listed first on this blog post. I don't know if that has significance here or not, but he's been working on basically security for activists since before I was in grad school, so like probably 2013 or earlier. After I think some of his friends, I want to say in Bahrain or something, got hacked by the government. I don't recall specifically, but he has a bunch of papers. He has a PhD from Berkeley, and he's just been really working on this type of stuff with Citizen Lab. And I'm pretty sure in the last, like, 3 to 5 years, it's mostly been NSO group stuff. But there's a lot of hacking team stuff back, I don't know, I want to say circa like 2017, 2018. but I think Hacking Team went under. Maybe they got bought by NSO Group.
I wouldn't be surprised. They kind of flamed out very publicly. So maybe they either got bought, maybe they got, gutted and bought, or they just kind of fell apart.
By the way, I don't know how connected the forced entry story, which is the public citizen story and the thing that prompted the update right now, how closely connected that is to the MIT Technology Review story about Optiv and Accuvant. There's like two kind of long-running stories right now about weaponized and marketed vulnerabilities. One of them is the NSO story about how there's a product company in Israel that you can, governments can just go buy the stuff from and, aim it at journalists and stuff like that, right? The other story is the one about a group of ex-US intelligence community people who went to work as quote-unquote mercenaries, which I'm fine with that characterization, and so we'll just call them mercenaries from now on, right? But they went to work as mercenaries for the UAE, for a specific team that the UAE put together, and themselves acquired and weaponized vulnerabilities. Like the team that they managed, according to the DOJ filings and according to the MIT Technology Review story, was doing some amount of their own kind of implant development work and weaponization work and stuff like that on their own. It would be weird if they weren't interrelated somehow, like if the UAE team for some reason wasn't working with NSO. In the DOJ filings, there's two companies that this UAE mercenary team, those mercenaries are all pleading guilty or something like that right now to felonies for breaking ITAR and stuff like that, right? Which is its own kind of interesting story. But in the filings, they apparently sourced vulnerabilities from two different companies, U.S. company. Oh, I guess the other one can't be NSO because they're both U.S. company 4 and U.S. company 5. And NSO is not a U.S. company. So yeah, I don't know what the relationship is. I have a bone to pick with the MIT Technology Review story, though. That story kind of centers around the role of Accuvant and Optiv in this story.
Yeah.
Where like the reveal is that one of the companies behind these vulnerabilities is Accuvant. That Accuvant sold to this mercenary team, stuff to let the UAE target journalists with, which I'm sure, by the way, is true. That's not my bone to pick with the story. But if you read the story, you'd get the impression, because they wrote it this way, that Accuvant is a small team in like Denver, Colorado, that works on, iOS vulnerabilities, and that's what Accuvant is. But if you're in the field, you know that Accuvant is not that at all. Accuvant is a giant consulting company. They're one of the larger kind of software security and network security consulting companies. They're called Optiv now.
And if you are in Denver, you'll know that one of the larger buildings downtown is the Optiv one. Possibly the tallest, I'm not sure.
That makes me sad, right? So I mean, I think there's a whole reputational thing here where so I think the reason this is interesting is because a lot of people work for Optiv. Like it's a totally mainstream, normal place to go do security consulting work. I knew they had like an exploit development program. I've got friends that have had like contacts with it or worked with it or whatever. I didn't realize that they were doing that for the quote-unquote intelligence community or the gray market intelligence community. People have kind of pointed out that if you're really good in this market, like if you've got contacts and you're a credible organization that builds and weaponizes vulnerabilities and sells them to like the NATO markets, right? That there's a whole pipeline of good contacts that you work with there, so you don't have this problem. And it's kind of a tell that maybe you're not good at doing this work if you end up selling to shady mercenary outfits in the UAE, because like the big time people that do this work for NATO players, right? The sense I get from people talking to me about this is that that's not what happens. Either way, though, right? Like, I don't know that you worry about it. Again, I feel like Accuvant, Optiv getting some of their just desserts here, right? But like, it would not be fair to assume that any random person that worked at Accuvant had anything the hell to do with this, right? Like, most of the people that do software security at Accuvant test web applications like for the people that built those web applications. They're not a tiny company in Denver that just kind of specializes in shady iOS exploits. And like the article itself, the MIT Technology Review article, like talks about how extensively the DOJ filings kind of established the role that Accuvant had in this. But if you look at the actual filings, it's like, a couple of sentences saying, okay, there's this US company 4 that sold us this exploit. The exploit wasn't usable as an implant. It basically, it told the user that they were compromised. And then like it's the kind of thing where you would build that to test a device for like a red team exercise or something like that. And then they took the red team tool and of course, changed changed it so it would be an actual, weaponized exploit.
So the mercenary group bought like the pen testing tool and then paid 2 random people that previously worked at Accuvant to turn it into a real exploit.
Yeah, either. I mean, it's horrible behavior, right? Like it is still on the management of Optiv. In fact, it's more on the management of Optiv because they've managed to tar a lot of people that do kind of totally benign work, just kind of professional software security people, with this brush of also, trying to get journalists killed, right? It is, it's fucked up that Optiv management let them do that. That was a decision they should not have made, right? But if you're reporting on this stuff, you should get these kinds of details right.
Did they do it within their capacity as Optiv employees or like as independent contractors?
This is in their capacity as Accuvant employees. So the timelines here are from like 2015 to 2017. And at that time, Optiv was a big company.
Yeah. Yeah, I mean, people, especially message board people who Thomas loves, like freak out about, like they're going to be coming for my black hat training. It's like, no, like it's perfectly fine to teach people how to write exploits, and to like even sell exploits, but like what you can't do is like provide support or build something for someone that you specifically know is doing something illegal. Like, yeah, you can.
I'm a little fuzzy on that, actually, right? I kind of wanted to come into like a thread like that, guns blazing, and saying, of course, you can teach exploit development to whoever you want, right? But they're charged under ITAR violations, right? They're under export controls. So there might be some threshold of training, past which you're no longer teaching people things, and now you're actually transferring essentially arms. Yeah. I don't know what the threshold is there, but it's an interesting question, right? Like, I would be, I'd be careful about doing that kind of work with people overseas. Thankfully, I don't do that kind of work, right? Yeah. But like if I did, that might be a thing I'd be careful about. It might be tricky to find a lawyer who can give you a good answer on that too.
Yeah, I mean, I wouldn't. Not that I'm competent enough to write actual exploits, but like I wouldn't do it with anyone that wasn't like in the U.S. government.
It's not hard to find people that will talk to you about Accuvant or Optiv, right? Again, big company, lots of people work there, lots of like pretty noisy people work there. Great, good noisy people, right? Or have worked there in the past. So like there are journalists that I've talked to that are really good at this. Okay. Keeping contacts in the field and talking to people and getting good sourcing. And then there are journalists who are not as good. And I wonder why people don't take the time to just ask around and see if they can get a conversation about, like, for instance, what is Accuvant, right? Or what was Accuvant in 2015?
Wait a minute, Thomas. Are you advocating for ethics and security journalism?
This is the second time this has happened to me. Like this happened to me with Eric Raymond last time, and now it's happening to me now with Gamergate. So thank you. I'll shut up now.
On your previous question about whether anyone has analyzed the patch, this link from Objective-C, they have definitely gone deep into looking at the specifics of the patch, and any of the other multiple functions have been patched in that. So I'll add a link to the show notes. Related to Apple, we talked about Apple's proposed client-side scanning system to try to look for child abuse imagery, known child abuse imagery. And after a lot of consternation in the public discourse, they have announced on a Friday, of course, because they announced it on a Friday and they, or Thursday, I forget. And on a Friday, they said they're going to pause on rolling it out for now. And then they had their September product announcement with a new iPhone and a new this and a new that.
And no new M1 MacBooks. I'm disappointed.
Yeah, I was like, am I going to have a MacBook Pro that I can buy? The answer is no, I cannot. You can get an iPad mini with a USB-C port, which is great because I just bought an iPad and I had to pick only 2 models that had a USB-C port. And so I had to spend extra money just for that USB-C port. But yeah, at that big, hoopla that they do, there was no announcement of any end-to-end encrypted iCloud, which kind of makes sense because the way that they would get away with announcing end-to-end encrypted iCloud is if they had this client-side scanning in their back pocket so law enforcement wouldn't get mad at them. So that happened. Okay.
They didn't even announce when iOS 15 is coming out. Like, we still don't have a date for it. There's new phones and, like, maybe not even an operating system. Yeah,
I'm actually concerned about that because not even this bug that they patched, this one they patched, but more recent ones that had to do with, circumventing Blastdoor and things like that. And people were like, hey, are you going to make this better? And they basically kind of hemmed and hawed and said, we're going to make improvements in iOS 15, which is coming soon. So we would really like it to come soon, but we don't know when soon is.
The betas are out. I don't know if people have
good.
taken a look at the binaries and checked to see if anything is different, but...
Cool. So that happened. That was fun. Please release iOS 15 for my singular iOS device and any patches to Mac OS, because I have several Macs. What else? The last week was fun because Chrome also patched some 0 days. They claimed that theirs were also known to be exploited in the wild. 2 of them were an out-of-bounds write in V8. V8 is the JavaScript engine that they use in all Chrome, Chromiums, Chromebooks, Chromedis. My Chromecast over there is running on Chrome OS, so anytime you run JavaScript, that's what V8 does. It does the running for you. And then a use after free in IndexedDB, which is the one of the databases that you can use from your browser, from your web app. Yet more 0-day vulnerabilities that would probably not exist if not for the use of memory unsafe languages. So, yay!
Yeah, and I just don't really see V8 getting much better. Like, I don't think it's a total tire fire, but like...
It's not.
There's gonna be, an O-day a quarter or whatever, and as long as it's written in C++. It's
gonna
Shrug
happen.
Emoji. While we're on the top of the Chrome, though, can we pour one out for the Chromecast Ultra 4K?
Yes!
Not, there's not even a 4K Chrome. Is there a 4K Android TV? I don't think there is. The one that I have doesn't even do 4K.
There is this bullshit, Chromecast with app Google TV. It's Google TV. It's not
I have
Chrome
one,
OS.
because they gave it out for free to YouTube TV customers.
Oh, fun. I hate it because it's not Chrome OS or whatever, Chromecast OS. It is Android TV with some weird compat but doesn't quite work Chromecast layer. And I literally got I think I got a used 4K Ultra Chromecast off of eBay without the power adapter, and it yells at me that I have the wrong power adapter because I do not like the Google TV. And I think the only way you can buy a new one is if you go to the New Zealand Google store and you order it from New Zealand.
So despite complaining that it's gone, for reasons, I have one that I'm not using, so I could probably send you the power adapter. This is this is the content people crave.
I love Chromecast. I love that it is I love that it patches itself every night and I see it do it and I love it. Yeah. So bring back the Chromecast Ultra or 4K or just Chrome OS 4K. Swap it out with Fuchsia because I know you've done that with one device. I love it. I will run it. It's great. I'm gonna get sidetracked on Fuchsia if I don't stop. So I'm gonna stop. Because we were looking at some of their Rust dependencies for crypto. We have suggestions.
I would just like to note that I believe the term is friend of the pod. Chris Palmer has switched to working on Fuchsia from Chrome.
Yeah.
And I think that is a negative for Chrome, but I think a positive for Fuchsia.
Absolutely.
So maybe we'll drag him on here once he's had some time to settle and he can tell us all the cool stuff.
So exciting. Oh, I have so many questions.
I've got nowhere to go with this, but I'm just reading the Chrome security update here and noting.
Yeah.
So one of the vulnerabilities was a use after free.
Yes.
That was by Marcin Towalski of Cisco Talos.
Ooh.
So congrats to Marcin Towalski at Cisco Talos. Note that Cisco Talos finding good browser vulnerabilities. A couple of different vulnerabilities from Theory, which I'd like to know more about Theory. I guess they're a Korean security research consultancy or company or whatever. 2 different researchers there, one on the out-of-bounds memory. I'm seeing out-of-bounds memory writes and assuming that those are the really bad ones, right? And then there's a couple of vulnerabilities from I don't know how to pronounce it. It's like Ulu University, the O-U-L-I, Ulu University, the Secure Programming Group, which is apparently a bunch of badasses because a couple of different researchers there. Also, high severity vulnerabilities, multiple in this release. So, I like that people are giving credit. I like that I can kind of keep track of who's doing good work here. And I guess pay attention to Ulu University, as always, Cisco Talos. And I guess I needed to go poke into, what's going on with Theory because they sound pretty awesome.
Yeah. And then the two that were cited as there were exploits in the wild are reported by Anonymous. So
thanks, Anonymous.
Thank you, Anonymous. Thank you very much for making things
not
more
that
secure.
Anonymous.
No, not
We're not
the
thanking them.
collective. Not the anonymous collective, blah, blah, blah. Some anonymous bug reporter. Thank you very much. All right, everything's on fire. Patch your Chromes. Patch all of your Apple software, please and thank you. It'll keep you and your loved ones secure.
Even my mom was forwarding patch your device stuff on Facebook. So
Yo.
I think the cat's out of the bag on this one. People are
Yes.
probably not getting that much value out of this. But
Well, still,
yes.
I
will echo my mom.
It was going around on TikTok. Like, several people are like, when there's a big Apple patch, I think people are fucking getting it. It's got that collective knowledge at this point, which is like both good and bad. I guess.
Deirdre, do you get to feel like better than everyone now because you're on a Pixel phone, and for the longest time people have been saying iPhone, and you could maybe make the case now that Pixel is a more secure operating system. I guess the downside is that your phone doesn't work because it's a Pixel, but
My phone
maybe there's
fine.
less remote zero-click O days.
For a very long time, I felt mildly superior because there was all sorts of features that I could do on my Android phone that you just were not allowed to do on iOS. And since I just got this iPad, I'm like, why can't I do blah? And it's just like, you just are not allowed to do that. And I'm frustrated by that. But now I get the bonus of being like, oh, I can do all this stuff and it's more secure. And I have slightly more choice about like what fucking browser runs under the hood. I can have more than one. Wow, like amazing. I can have something other than WebKit running under the hood. I have fucking 6 browsers running on this phone. It's great, and not all of them are based on Chromium. I swear to God.
I think
You're really selling me here.
So slightly, yes.
We're both wondering if you need some kind of help.
Because I have so many browsers.
I feel like it's not a thing that was missing from my life was lots of different browsers.
I spent a long time as primarily a web application developer, and so I still have opinions in a collection of browsers. And I would say...
Is one of them Opera?
No longer. Once upon a time, yes, but
is
no
Opera
longer.
Chrome these days?
It switched over to Chromium, I think. Yeah. It used to be that you needed an IE derivative, you needed a Chrome derivative, you needed a WebKit derivative, and you needed Mozilla, and you needed, Opera, because they were all different lineages. And now almost all of them are, including Edge, Opera, and, Brave and Chrome are all the same lineage. They're all Chromium-based, and then Mozilla. So you only have the 3 now. You have WebKit-based, Chrome-based, and Firefox. And, that's basically it. It's kind of good and also kind of meh.
Opera mostly exists today to be a fraud signal. So I wish I was kidding. Hey, both of you.
Yes.
We should have some secure messenger opinions. I think we could have some opinions about. Well, we could start with Matrix.
Okay.
I'm having trouble fathoming what happened there.
Yeah. So I haven't dug into the protocol, but the description of the bug is enough to make me think, what the fuck is going on with this protocol?
Well, I don't know if it's the protocol because it seemed to be a vulnerability in their SDK. So
yes, but
that.
the bug should not have been writable in a situation where the protocol makes any sense.
Okay.
So as far as I can tell, there's a feature in Matrix that lets you export a key from one of your devices to another one of your devices that you can get message history, which you could debate about whether or not that's a good feature. I think it's fine. But if you think about how this should work, is you have a known set of devices and you need to get an authenticated message from that device that says send the key to that device from whatever device it got sent to. And somehow there is a bug in Matrix where you could take a message from an old device that you had removed. So you had some device, you removed it. Somehow an attacker could spoof a message from the old device and get you to send them their message keys. And I just don't understand how the first step of the protocol isn't who is the sender of this message, and then what is the key for the sender of this message, and then does it work under that key, right? like, I understand, inner versus outer bugs of where, like, the person who you authenticated as isn't the person that's, like, trying to do some action and things like that. But I just don't understand, like, how you build a protocol where the share keys message, like, has the opportunity to do that. Like, who the sender is.
You see, it's not a big deal because exploiting this vulnerability to read encrypted messages requires gaining control over the recipient's accounts. Ergo, it requires either compromising their credentials or compromising their home server. You have to compromise the home server to actually exploit this vulnerability, David.
Isn't that the exact threat model that it's supposed to defend against? The home server being malicious?
I don't think you understand. You have to compromise the server to do this.
It's supposed to. That's the whole point of the end-to-end encryption.
Yeah.
It's supposed to fail closed, not fail, give me all your keys.
I think Matrix is kind of a cool project. I think it's like, they're trying to do encrypted IRC with like roughly the ergonomics and like the federation model of IRC. So like there's a notion of, unlike Signal where Signal runs the servers for you, like you could theoretically build your own Signal server, but like...
I think their protocol, which they called OHM, it's basically a follow-on to the Signal protocol with kind of this other stuff on it that supports this kind of federation thing. Yeah.
I like the idea of it as well. It's just I don't know what's going on with it. I don't know anyone that works on it, which like I should know somebody that works on it. Like it's like a little pretentious, but like at the same time, like if you said such and such is working on Matrix, like I probably should have at least heard their name at some point. Like that's kind of how I evaluate TLS libraries. And I just don't know. So I like the idea, though, because I'm just really frustrated with Slack. And like, I wouldn't want to use Discord at, like, a company. But
I think someone from Matrix is collaborating on the MLS spec with other people, which is basically trying to do end-to-end encrypted style Slack, like, group messaging. Think Signal groups, but it's actually scalable for like hundreds or thousands of people in your group messenger. And it's using these, trees and, more, yet again, Merkle trees to manage the state of all these groups of keys and people who add and join and they get ratcheted and everyone gets, rotated and all that sort of stuff. I think someone from Matrix is collaborating on that, but that protocol, MLS, is not OHM or mega ohm, and I'm saying OLM. The whole, being able to share keys, I would give you the willies to have that implemented at all, even if you had a good reason for it, or you think you have a good reason for it. But yeah.
MLS is very cool. I think it's, I haven't had to implement a secure messaging thing, so I can't like say with certainty that it's well done because I don't know what would come up when you actually try to implement it, but it looks very well done.
They are nailing down all the shitty cases of a large group end-to-end ratcheted messenger. There's a nice implementation in Rust for the protocol. They've been working on the spec. I see updates every week, if not day. It has to go through the IATF process, which I think we all have opinions on. That's the way they're doing it. But they're doing it.
I think the main downside is just no one uses it in a like product at the moment.
Yeah.
People are implementing it, but like there's not like the MLS messenger.
Yeah.
On the upside, it'll have a remote debugging feature with heartbeat messages soon.
Oh man, Richard Barnes has been driving a lot, or at least he was driving a lot of the management of that list, and like, Richard Barnes is not the type of person to say yes lightly. I was at RWC a couple years back when I was in San Jose. I want to say this would have been 2019, maybe. And some like blockchain person came up to me, and I happened to be talking to Richard and Eric Riscola, the like author of the TLS RFC. Basically, and they started talking about blockchain stuff, and I opted out of the conversation. But this person, like, you could not imagine a worse fate for like this blockchain person that perhaps did not know a lot about the actual underlying cryptography, getting stuck with like Eric and Richard, and getting grilled like he's on an IETF mailing list. But like when I left, there were not many people left at like the happy hour, and somehow they were still talking in the corner, and I'm just like, this poor soul.
It's like you're either having a great time or the worst time. To correct myself, it's not Matrix, it is people from Wire, the Wire Messenger, who are collaborating on MLS. And I just threw a link in our show notes on MLS. MLS is cool. Richard Barnes is now at Cisco. Like, if this gets deployed into some sort of like Cisco like group messenger, that's pretty cool, you know. And then maybe other people will like absorb that into Slack. I don't know, man. Slack is like a Electron-based app or a web browser-based app, and it's already janky. And so I don't even want to think about adding, messaging layer security to Slack as it exists, because the web app without any of that is already giving me grief.
It's just not going to happen. That's not a feature anyone that pays for Slack wants.
Well, people pay for wire deployments. I don't know if there's a thing that Amazon has made that's just basically like recycling wire or something like it, because they want secure comms, but they don't want to use Slack. They want it encrypted.
There's like Chime or whatever, right? But it's
Chime is just self-hosted. I don't think it's encrypted.
Yeah, it's secure in the sense that you control the servers, right? But it's not secure in the sense of like MLS.
And you can deploy Chime on your AWS account, which is very because you don't want Amazon to run it. You want Amazon to run it as a service in your Amazon Web Services account. Yeah.
You want Amazon to run it with extra steps. Sorry about the bug, Matrix. Thanks for fixing it.
And good disclosure, I think.
Yeah. Everything that I saw seemed reasonable.
We had some follow-up to the JWT conversation we had with Jonathan Rudenberg. So I gather there's a Paceto update. So after we did the JWT conversation with Jonathan, I wrote a long blog post, which basically just plagiarized the conversation that we had, which is a thing I do. Just be aware that that's going to keep happening. And I kind of did a breakdown of the different token formats, and I gave some props to, kind of the protobuf token thing that you guys had been talking about. I doubt anyone's going to use it, but still. And I was mildly critical of Paceto. I'm more than mildly critical of the overall concept, not Paceto itself. I think Paceto is a fine realization of these JavaScript tokens, but I don't love JavaScript tokens. I kind of didn't see like a great place that fit into the ecosystem of like different token stuff. And I pointed out that Neil Madden in the CFRG, again, my advice to the Paceto people is don't engage the IETF with your custom token format thing. No good will come of it. But I guess some good did come of it in that Neil Madden pointed out that they had the HMAC versus public key confusion vulnerability, the same one that JWT had. And I guess Paragon has responded by trying to mitigate that. What do we think of the mitigations?
Looks nice. Well, there was the confusion, and the changes that came include ...
It's interesting because they updated their documentation in two places. I guess that if they had those documentation updates beforehand, it probably wouldn't have changed what I wrote, right? Like they had already kind of documented that the potential for that vulnerability existed, and my qualm would have been that the potential for that vulnerability should not exist. But they also, the interesting third thing they did is to have negative test cases now. So that in their test suite, they explicitly test for, do you have this HMAC versus public key type confusion vulnerability, which is cool.
Yes.
I don't know how I feel about using test suites to mitigate vulnerabilities that don't necessarily have to be there by design, but are now there by design.
So I'm not sure. So there's definitely like the HMAC RSA confusion, and we talked about that previous episodes, and you can Google it and learn how it works. It's very straightforward. I don't know that there's like even if you tried, that there's like a AEAD and ED 25519 type confusion vulnerability. Like I just don't, or even AEAD and HMAC maybe. Maybe you need one side to be HMAC. That's probably what it is. But
yeah, I think so.
That would make sense. And so if the two options are, a modern signature and an AEAD, like you can't really screw up your header. And like that's because the thing that you do is you take the header and you put it in as the associated data in the AEAD. So if someone has swapped out the header, like it no longer works correctly. So I guess the thing I would say is that the deprecating the old versions spoke to me more than the negative test cases, although I do like them, because like I just don't think the type confusion really exists if you're using an AAD correctly, which you know is props to both Pasado and to AATs, which are great.
Yeah.
Yep, I'm there with you guys. I mean, it's definitely it's a positive step. It was already a credible thing to use. If Pasado is your thing, go with my blessing, right?
Yeah.
But yeah, I mean, good response. Happy to see it.
Yeah. Thank you to the authors behind Pasado. I'm always a favor of negative test vectors, even if it's not something like a JWT or a Pasado or whatever, but like it's not just sufficient to have like golden path test cases. Like this should work. You should have a thing, especially for compatibility if you're trying to do anything that's like an interoperable implementation of a protocol or, you know, a verification scheme or something like that, to be like, not only should these things pass, these things should fail. And if they don't fail, you are not compatible or you're insecure or something like that. So I am always happy to see more negative test cases on whatever it is. You should
be doing that, like, when you are using JWTs, Pasados, whatever, in like some application, like your application should have a test somewhere that like makes sure that the invalid ones or the missing ones like don't work.
Yeah.
Regardless of which library you're using or which token format.
Yeah. Okay, so related to, I don't know, Go cryptography and TLS, and one of our favorite people, Filippo, who was on our second episode. Go TLS, the default cipher suites provided if you just use the TLS implementation in the Go standard library, has made some changes to how they pick their cipher suites when they're negotiating TLS. They're all great choices. They're basically automating, at least for, like, I am not just because I know Filippo, because I agree with everything that the Go team did. These are basically ways of making a bunch of programmatic choices between how, like, what key agreement you choose, what block cipher mode you use, what, like, you know, HMAC or hash function you use, depending on the other parameters of the client and the server negotiating this TLS session. For everything below TLS 1.2, you've got a bunch of things you have to negotiate. And part of the great thing about TLS 1.3 is that you don't have as much stuff to negotiate because it's just kind of picked by TLS 1.3. You have a much smaller set and they're all good choices. For TLS 1.2 and below, they're not also great choices. So Go basically did is automate the sort of decision tree based on the parameters of the session to pick the good stuff.
That's one way to put it.
One more point is that they basically encoded what the Mozilla SSL config web app has been doing and providing for a very long time, which is like, give me information about your clients and your server and the things you need to support for your TLS, and we will spit out a config for like Apache or whatever it is to do the right, like, top to bottom, first priority, second priority, third priority of TLS config to get the best security for your performance and device choices. And basically Go took that same sort of rubric and encoded it into their Go cipher suites. I think this is good.
Yeah, like a good rule of thumb with Go cryptography is whatever Filippo says you should do is what you should do. You're like, it's pretty straightforward, right? I can tell you how the internet sees this. Which is they took our freedoms, our precious freedoms. There's a whole thread like this breaks the Go compatibility promise. I have kind of like only one thing to say about this, which is at least a couple of different people complained that Go is removing some of your flexibility in controlling cipher suites in Go TLS, which is a good thing, right? Because they're right and they're thinking about this more than you're thinking about this, right? But there are people that build test tools using the Go standard library that need precise control over what ciphers and stuff they're using because that's one of the things they're testing, right?
That includes me. I've done this.
I just want to put a word in for the right way to do this. Somebody said, like, well, what do you expect them to do? Fork the TLS library and the standard library?
That is exactly what we did.
Yes, this is what everyone does. So if you haven't done this yet, people complaining about this change at Go, the next thing you should do is vendor out the TLS library and fork it and control it yourself. Everyone who's ever written a serious TLS testing tool with Go even before any of these changes happened, was already doing this. Just because like there's so much, it's such a great library, the Go TLS library, because it's very easy to change. It's very easy to muck with and add instrumentation to, and it compiles quickly, and there aren't dependencies, and it just works. It's a great basis for building tools and stuff. But yeah, like the thing that makes it great is you can just forklift it out of the standard library and make whatever changes you want. So I just want to put a word in, like if you're complaining about this, you're missing the point of this library.
Yeah, and I'll take the opportunity to plug the zcrypto library, which is underneath the zmap org on GitHub, which is exactly that. I don't think it has TLS 1.3 at the moment, which is a little embarrassing. I haven't worked on it in a while, but I think someone is actively working on that. But if you need some export ciphers, or you need some RC2, credit to Thomas's implementation of RC2.
Silence!
Hey, you got a bottle of gin in exchange for licensing at RC2 implementation, so that some lawyer would shut up.
I hate all of you so much.
I had to check a bag when I flew to Vegas to bring you that bottle of gin.
I love gin and I appreciate you, but I hate you till the end of the earth.
Did he make you? Well, no, you already wrote it, and you had to license.
All I did was write RC2 and post it on GitHub, and then all this horrible stuff happened because people used it.
That's what you get for writing RC2.
Here's some random crypto code on a page. Let's use it.
I mean, that's how the internet goes, right? Like,
hey, that library is why we were able to measure the drown attack, which, if I recall, is one of your favorite things on the internet. Maybe you can explain to me how it works one day.
It is my favorite TLS attack, bar none, right? It's also, I think it's the reason why I have like the Arctic Code Vault icon in my thing, is that stupid RC2 library.
Oh, that's funny. It's going to be preserved for all time.
That's why I wrote it, for my legacy.
I think one of the last things we have for today, there was a cloud vulnerability in Azure where cross-tenant jobs on their instances were exposed. Kubernetes cross-tenant, Cosmos DB cross-tenant, and remote code execution in VMs by removing an authorization header.
Did you see the vulnerability? It's great.
No, please do.
Oh, it's wonderful. They run. I don't have all the details. I didn't take the time. My wife Erin spent a lot more time looking at this than I did, and she's like, hat tip to her to tipping me off about this, right?
Yeah.
But I guess on Azure, all these systems run like a different series of agents that are kind of the same way. I guess whatever I'm trying to remember the thing in EC2 where you can run tasks instead of just jobs, but that also involves an agent. But anyways, they run agents on all these machines because agents are always great, and I've been saying that forever. And one of them is authenticated. There's an authentication header. It's HTTP is the protocol that it speaks. And you send an authorization header with, I think, a token in it, right? And the vulnerability is, wait for it, you can just not send the authentication header, and it just stays open.
Oh, no.
I just want to say this. Back in 2005, my friend Jeremy Rausch had me kind of work alongside him on a web application pen test. I'd been a vulnerability researcher forever, but I hadn't been a consultant before. This is my first billable consulting project. And on that project, I'd never really done web stuff, too. It was like the first web assessment I'd ever done. Before that, it had all been like...
Did the internet even exist in 2005?
Oh.
Barely. But I remember I looked up what the web vulnerabilities were, and I looked up SQL injection, and I typed into the login field and the password field, I typed quote or quote equals quote, and it worked. Like I logged in with a SQL injection on the password field because I guess it was looking passwords up in the database or something. It's great, whatever. And from that point on, every time I was on an assessment, for a long time I believed, it's possible that if I just put quote or quote equals quote into the password field, I'm going to be able to log in because that's a vulnerability that exists. Of course, that's not a vulnerability that exists. It's like a heartbreaking vulnerability of staggering beauty. You're never going to see it again in your whole lifetime. And I feel like the Azure agent vulnerability is another example of that, where you're never going to see a vulnerability as great as the remote code execution from just leaving the authorization header out of the HTTP request. You'll try it from that. Those people are forever cursed to try that vulnerability over and over again and never see it again.
He's like, I just maybe I might see it one more day. God, Azure was never going to be my top recommended cloud if you need to use someone else's computer to do your computing.
That would be fly.io.
So can you run an Active Directory stack for me, Thomas?
I could try.
Because what I really want is a globally distributed Active Directory.
Oh, Jesus Christ.
Or, excuse me, Active the Directory.
Thomas is just going to go in the code mines and like tomorrow he'll be like, okay, where do you want it?
No, I'm just going to post on Slack, and Jason Donnenfeld will write it for me in 2 hours.
Oh my God.
It's worked for me like 3 times now.
Jesus Christ. Powers. Great power. I guess, like, you know, this sucks. I really don't like to see this from, you know, your cloud, which you're just trusting to not, you know, spin up these things on their hypervisors and not be failing open. The only thing I would really have to say about this is that Signal to Service requires SGX to underpin several of their recently deployed services, including their private contact discovery and some of their group key management recovery stuff. And it's underpinned by doing secure compute in SGX. And as far as I know, Azure is one of the few clouds that actually allow you to do anything with SGX at any kind of scale. I think the other one might be IBM. So it feels, one, SGX is a leaky piece of crap, not even getting to the side channels. Like, there seems to be yet another really scary, just break, leak vulnerability of SGX almost every year at Real World Crypto or other places. Maybe, I forget if there's one at Black Hat very frequently. Before you even get to the sort of side channels about like doing processing over, you know, secret keys in the secure environment and leaking for someone else. So when one of the only clouds that lets you use SGX is also just failing open like this, feels bad. Just feels bad, and it feels bad that, you know, Signal, supposedly the most secure private messenger, relies on this sort of infrastructure. So, I don't know. Mitigate that? I don't know how you mitigate that if you're already deployed on it. So, that's what I have to say about that. Anything else?
I feel like we're at our best at the ends of these podcasts when we're all a little bit punchy. So like a pro tip from now on might just be to skip to like the last 30 minutes of these things.
Well, you have to get through the first to get to the end where you get all punchy. The journey is part of getting there. I don't know.
Do any of you know anybody who's used IBM Cloud?
Not.
Yes.
Okay. Only because they had a quantum computer as a service thing. And I'm not joking. Like, they have like a thing that's like, you know, give me a thing that's like targeting this, like, you know, intermediate representation, and then we will like run it on our quantum computer or whatever. That's
just like a Rigetti or something?
Not a Rigetti. Like, they have an actual quantum computer. They have this whole sort of like sim environment, like software that will target, you know, a quantum circuit, and then in theory it would also eventually get run on a real quantum computer with qubits and all the, you know, all that crap. That's the only thing I'm aware of.
It's a feature I'm sure we'll launch at Fly soon too. My partners at Fly were at a company called Compose.io that did managed Postgres that got bought by IBM.
Yeah.
And that was the company they did just before Fly. So I do know people who have been involved in IBM Cloud stuff. So if we have IBM Cloud questions, I can bounce them off of Kurt and get them answered. So maybe we can ask him about Signal and SGX.
Yeah, like my only question would be like, what is the SGX story of like deploying things that need to be kind of like at a cloud global scale, distributing this sort of, it's sort of like Raft with secure computation and SGX and stuff. They have a couple blog posts about it, but yeah.
Kurt, if you're listening.
Like, it's very curious if there are any better stories about managing that, because it doesn't sound fun. It sounds like a lot of work. So if they can do it any better, maybe that's something that they can sell to someone like Signal.
That feels like a lot of news.
Yeah. Yeah, it's been a little busy.
I have many fewer browser tabs open now, so thank you for that.
Yeah. Everyone patch your Apple software, your Chrome, your Matrix, and your Element, and, you know, cycle your VMs on Azure or something if they haven't been forced reboot already.
run your Passeto test cases?
Yes. If you are an interoperable version of Passeto tokens, make sure that you integrate those negative test cases into your builds.
Cool. And keep an eye out for the upcoming Restart Your Fly client so that you get the Active Directory feature.
Uh-huh.
And on that note,